Okay, so .4 is about the graphs of sine and cosine. So the only thing I require you to know is what they look like, which I'll show you in a moment. I'm not going to make you graph it by hand, but I require you to just know what they look like, be able to identify them. And given an equation, can you find the amplitude, the phase shift, or the period, that type of stuff. So let me give you those formulas. So amplitude and period. Okay. So the definition is, so the amplitude, the amplitude of y equal to a sine x and y equal to a cosine x represents half the distance between the maximum or max and min values. Of the functions. So the amplitude is simply just the absolute value of the a, lowercase a in front of the sine. Okay, so let me show you what they look like real quick. Okay, let's get rid of that. So y equals sine x. So this is the original sine. It always starts at 0 and then has a peak at pi over 2. So these values are coming from the unit circle right here. These are the main points, I guess. But as you can see, it repeats itself, right? So from here to here, and then it starts over again. So every 2 pi it starts over. So if I start at 0, remember how we said going around 360, eventually we get back to 2 pi. So starting point 0, 1, 0, -1, and then start over 0, 1, etc. Okay, cosine is very similar. It just starts in a different spot. So let me turn that off. So cosine, remember, at 0, if you look at your circle, cosine of 0 is 1, right? Cosine of pi over 2 is 0. Cosine of pi is -1. So then that eventually starts over at 2 pi, getting us back to 1. These are periodic functions. They keep on going forever. Now, looking at our notes, we said that the letter A is the amplitude, right? So there's the number in front of here is a 1 because I didn't write it. So the highest point is 1. The lowest point is -1. Now, if I were to change this into a 2, now the amplitude has increased to 2, -2, right? but it's still pretty much the same. So that's what the amplitude does. So if they ask you on the homework, given the amplitude, you just look at the number in front of the cosine, okay? Or sine. But visually, it scales the graph by 2 points, a maximum of 2, minimum of -2, where the original looks like that. Okay, so I just expect you to remember what they look like. That's really about it. Now, let's see here. The first couple of questions we'll talk about amplitude, phase shift, that type of stuff. Okay, so let's move on. To period. So I'll just erase that part over here. Okay. Let B be a positive real number the period of y equal to a sine x and y equal to a cosine x is given by this formula. So if they ask for the period, all you have to do is use this here. So the period will equal 2 pi divided by, oops, forgot one little detail here. The sine x should have a, it should be sine bx and cosine bx. I forgot. Sorry about that. bx. So 2 pi over b. So whatever number is next to the x, that's going to be what divides into 2 pi. So the original is going to go around the circle in one period of 2 pi. But if you change that number, the periods will change. So let me show you visually what that looks like. Okay, so I'm going to delete the sine there. So this is the original cosine. So if I were to change this into cosine of 2x, notice how the black one is 2 times faster now, right? Than the purple one. And what does faster mean? All right, let's look at this. The period is ending twice as fast for the black one. Look how soon it repeats itself. Right, starts here, goes down, then up again, starts over, down, then up again for the black one. The purple, it would go down, then up, but it would take longer to get here. It would take 2 pi versus the black one, it gets there at 1 pi, right? So this period ends in 2 pi versus this one ends in 1 pi. Okay, now if you were to find the actual period, right, you take this 2 and divide into 2 pi. 2 pi divided by 2 is going to be pi, right, which we can already see visually. It ends in 1 pi and starts over. That's what period means. It's how long it takes for it to repeat itself or to complete one cycle. The originals take 2 pi. If there's a number here, it's going to change the period. Now, let's say let's compare that to a half real quick, but you guys have any questions on period so far before I continue some more? Okay. I put parentheses just to be safe. Okay, so it looks kind of messy. So let me turn off the black one. So the original, we said, repeats itself in 2 pi, right? So does so does sine. Now look at the red one, right? The red one actually takes longer now because it's half as fast, meaning its period goes out all the way till 4 pi. So it takes 4 pi until it repeats itself versus the purple, it repeats itself at 2 pi. The cycle ends 1 period. Okay, so you can find that using the formula. When they ask you what is the period of cosine 2x, you would just use that b or the half x. Okay. Any questions on period? Okay, so let me know. And we'll do some examples in a moment. Okay. All right, so let's look at the homework problems and start our examples. So that's the theory behind it, right? So look at number 5 here. It says, find the period and amplitude. So this is example 1, problem 5 from your homework. So he can see right away, right? The number on the sign at 6 is the amplitude. So we just really write that down. That's it. Find the period and amplitude of y equal to 6 sine 3x. Let me switch over. Okay. So amplitude is the a, right? From the formula. Absolute value of a. So if it was -6, you would write down 6, not -6. That's why they put the bars on there. That's going to be 6. Period, we said, is equal to 2 pi divided by b. Our b is going to be what for this question?
3.
Yeah, it's just the 3 on the x, right? So the period is going to be every 2 pi thirds, it repeats itself. So that's it. Any questions on finding the period and amplitude? That's what they did here and here. So 5, 6, 7 is pretty much the exact same thing. They just start putting harder numbers. So let's move on. Guys, I have no question about amplitude or period. Okay, here's some theory questions. It says, describe the relationship between the graphs of f and g. Consider amplitude, period, and shifts. I don't talk about shifts just yet, but let's look at this. The original is just the original cosine, f. G is cosine 3x. So we did something similar just a moment ago. So what is the relationship between these two, right? What does the 3 do to the original graph?
G has a longer period.
Let's see. Let's look at it, right? If we're not sure, we can always plug it in, right? So the original ends at 2 pi, right? Okay. The 3x looks like it's moving pretty fast. We're cycling pretty fast. So I think it repeats itself here. So it's 3 times faster, but the way we should phrase it is it has a period that is 3 times shorter because it's faster. Does that make sense? So that's what this is saying right here. The graph of G has a period of 1/3 times as long as the original period of F. And there's no, the amplitudes are the same. So them talking about amplitudes is just wrong right away, right? The only thing that we see is a difference in period based on what we talked about. Vertical shift, that has to do with numbers outside, and there is no numbers. And we haven't even talked about that anyway, so there is no shifting here for number 8. Anyway, so as you can see, it's not too horrible. Let me look at the questions here. Let's look at number 14. Sine 4x and 7 plus sine 4x, right? So what is this 7 going to do? What do you guys think? They were the same graphs, but one had a...
Gonna shift it up.
Yeah, so this is when they start shifting. Exactly. So there's the original, the purple, +7 is a vertical shift. -7 would be a negative shift, right? Oops. Oops. So you just simply answer, yeah, this is a vertical shift of 7 units. So nothing insane. This is stuff that I'm sure you saw in college algebra or before. Okay. So that's about it. I'm gonna leave the rest to you. These are just theory questions on what does it mean, more in depth into period and amplitude over and over again. I'll probably delete some of these. Let me see here. This one looks weird, unnecessary. Oh. Nah, I don't want to do that either. I'll leave one of those just because it's cool.
You could just leave 3.
There we go. These you just graph yourself. So you just put it in your calculator or in Desmos and you'll be fine. All right, so I'll let you work on these. I'm going to move on to 365. Do you have any questions on these ideas? It's not too bad, right? Okay. Yeah, there's not much to do, so I'm going to move on. One moment. 1 second. Where is the unit circle? There it is. Sorry. I should just leave it open all the time. Okay. So we said tangent is sine over cosine. So whenever the x value is 0, so basically whenever I line up a multiple of pi over 2, 3 pi over 2, then if I go again and again and again forever, all those points, as you saw on that graph, is going to cause asymptotes. So all these asymptotes right here, as you can see, right, is the values x equal to pi over 2. And then the next one, the next multiple of that, 3 pi over 2 is the next one. And then etc. So anyway, so that's what the tangent looks like. So then the next three are going to be the reciprocals. So all I want you to know is, what do they look like? Reciprocal of sine is cosecant, right? Reciprocal of cosine is secant. Reciprocal of tangent is cotangent. Let's go one at a time. So it's kind of, so here are the reciprocals of sine and cosecant. So if I were to force you to graph these by hand, which I won't, you would have to be able to, you would have to graph the sine first and then graph the cosecant up top based off its asymptotes. And those asymptotes are going to be whenever sine is 0, because cosecant is 1 over sine, right? So whenever sine is 0, that would cause a problem. And that's why you have these shapes. So just have an idea, or if you want to do a little sketch in your notes, what they look like. That's all you're going to need. Reciprocal of sine, cosine, and is secant. So see, very similar. It's just shifted a little bit to the left, all right? Because they have a different starting point. Tangent and cotangent are just really mirrored. They're in almost like inverses of each other. But don't worry, I'm not going to make you graph these by hand. So all you have to be able to do is know what the values are on the circle, unit circle, be able to find amplitude and periods, and you should be good for that entire section. But let me double check the formulas for 6.5. I think the period formula might be different. 1 second. Pretty sure it is. Where is it? In the book. These are just sine and cosine. It should be here. For tangent. Let me check a different book. 1 second. Yeah, here it is. Amplitude will be the same. So 6.5 graphs of tangent, secant, cosecant, cotangent. So we already looked at it. We already saw what they look like. The amplitude for tangent is the same, but let's go ahead and write it. For tan tangent y equal to a tangent of bx is going to be this. Just the a, same thing. Period, though, is going to be pi over b, absolute value of b, actually. Okay. And let me double check the secant. Pretty sure those are the same, but just in case. I am paranoid. Yeah. The secant, cosecant are the same as the sine and cosine. The amplitude and the period will be the same. So don't worry about that. The only one that changed is tangent and cotangent. Okay. Yeah, same for that. So let me go back to the notes on 6.4. So right here, secant, same for secant and cosecant. Same for secant and cosecant. Okay, there we go. I got all the stuff we need in one place. Okay. All right, so let's look at the questions and see if there's anything really worth doing. I think they're all pretty much the same.
I'm sorry, sir. Could you go back to that page for a second so I could write that down?
Yeah, sure.
Thank you.
Sorry about that.
I got it. Thank you.
Okay. So there's not much to do. It's really all just graphing and finding the period. So let's see if we can solve for stuff. All right, so number, hit save first. I think I deleted a couple before I forget. So my number 4, is I just edit this homework. The period of cosecant x, right? So example 1, problem 4. Find the period of cosecant y equals cosecant x. So the formula is still going to be the same. Let me switch over. Period is going to equal.
Since there's only the x, it's 2 pi, right?
Yeah, it's just 2 pi over 1, right? Exactly. That's it. Over here, they just want you to match the function. So you would just graph it in Desmos or on your calculator. I'm not gonna make you do it by hand, but you could by plugging in numbers from the unit circle and then slowly plotting them. But if you know what tangent looks like, you know that it can't be these first two, A or B, right? It has to be one of these because that's the shape when we looked at them. So you remember the shape, you can kind of eliminate answers. It's not negative in front, so it's not going to be reflected. See how this one is reflected? So it's got to be this one. So even without doing any kind of math or thinking, I know that it's going to be C because it has the general shape as of the original tangent, and it's not reflected. These look like secant and cosecant, so it cannot be those. You can easily just graph this on your machine or Desmos, and you can verify that it is indeed C. You can also plug in some of these numbers, like 0 and pi over 2 would be like right here, and see if it's equal to 1. Plugging in those numbers here would also verify this if you don't have a calculator. Okay, so this is the same deal. Cotangent looks like a tangent, right? So it has to be this one of these shapes, these S-type shapes. So I'm like, okay, well, this looks like normal tangent because we just talked about it, right? So it can't be this one, and it's not these two. So by elimination, it has to be this. You would verify it by graphing. There's not really much to do. So when it comes to the exam, I'm not going to make you really do anything if it just tells you to graph. Just pick the right graph and you're done. Okay. I don't like to spend too much time on graphing. It's the same deal here. But anyway, yeah, so they're all just really graph it and verify graph, which one, pick the right graph over and over again. So it should be a pretty chill homework. So 6.4 and 6.5 is pretty much the same thing. They may ask for some periods and amplitudes, but most of them will be just graph. You guys have any questions on 6.4 or 6.5? Does that make sense? Okay, you guys have any homework questions that you were struggling with from 6.4, 6.3, or 6.2? You can do some of those if you like. We've got a bunch of extra time. Excuse me.
So still no word on whether or not we're gonna have to get COVID tested every week.
Let's see. Yes, you will need to be tested every week unless we can get permission to change. Yeah, it looks like everyone wants to stay remote. Okay. So Tuesday, Thursday, we'll just stay remote, and I'm gonna let them know that you're all. I got to figure out the process to change it since you all seem to be okay with it.
Do we still need to get tested this week so we don't get dropped?
I would go ahead and get tested this week, just to be safe, because I don't know how long it's gonna take. Because I don't know if they're gonna say yes for one to change the classification of the course. But I don't know.
If we get swabbed at our job, can we just bring in documentation for that, even if it's the same day?
I'll ask if they're cool with that. I feel like they should be, especially if it's like a legitimate test.
This
Yeah, 'cause
might
I think
sound
my
stupid.
job's about to start doing it too.
This might sound stupid, but a lot of places won't accept the test results from other places. They'll make you do it anyways.
I see.
Like my job, I work for the military. So whenever they swab me, even if somebody else has already done it, if I got like lab results or whatever, and I bring it to them, they'll be like, no, we need to actually do it ourselves.